All right, let's go for it. Let's dig in. It is Thursday, April 21st. This is the second video of the morning for the second day in a row. Crazy. Okay, one thing I learned from the last video is when I watch these back and I keep taking the pen caps on and off, it's distracting and noisy and I think it's annoying. So for this one, I'm just going to keep the caps off. So, as the kids say, no cap. This is a no cap video. Not only that, it's bussin'. Yeah. Here we go. Hold on tight. Buckle those seat belts, except buses do not have them. Here's another question that came up in class yesterday, and I think this is worth a little dive into to find the deeper meaning, which we're always seeking in life. Okay? We have this thing that says negative x equals 6, and here's some questions I got about that from real life students. What do I do? Isn't this already done? Is this a trick? Hey, all those are fair questions, and I kind of wonder the same thing. Well, let's establish a little prior knowledge, stuff that you already know, okay? And then I'm just going to connect that to this problem, and you'll go, oh, I already know how to do that. That's my only job as a teacher, is to make you believe that you already know how to do things, because the thing is, you do. So before, what if we had just a simple one like this, 2x equals 12. What would you do? We see that we're multiplying, so we learned inverse operations. We learned to solve by division. If I see multiplying, I'm going to divide to solve by the coefficient, in this case 2, both sides, and then we end up with a nice, neat, everything's positive and beautiful. We love it. Then, that was easy, so we make it a little more complicated. Let's say we had negative 2x equals 12. Well, it seems logical if we divided by the coefficient and it was positive in this case, right? We had a little invisible sign there. So it's really no different now. Math has a lot of little invisible signs and assumptions. Let's go ahead and do the same thing. We keep the sign, we still see multiplication, and we divide by the coefficient. Okay, so now I have x is negative 6 because a positive divided by a negative, do they have the same sign? No. That means the result is negative. Remember that? Okay, so there's our prior knowledge. Hopefully you agree that this all looks like stuff you know. Now let's take it to this thing that looks new and different. What does this negative x actually mean? Well, there's another invisible thing happening here. How many x's are there? 1. So imagine this. There is a coefficient. What? I thought it was just negative x. Well, it is. But what does this mean? That's positive, right? If it just said that, you would say, oh, x equals 6. And I would ask, is that positive or negative? You'd say positive. Well, this one's negative. How many x's are there with the positive? There's 1, so that does have a coefficient. It's just invisible. Okay? This one also has an invisible coefficient, but just like over here, the sign was negative up here, but now we can see it. That should not confuse us once we understand we're seeing positive signs. This 6 has a positive sign next to it. Do you see it? Of course not. It's invisible. And the bus is going that way. So I have this negative coefficient, and if I follow the same things that you agreed with me on this stuff, right? This works. We divide both sides by the coefficient. So let's do that here. That turns, including the sign, that turns the x into what we like. And we have a simple little division problem over here. Do they have the same sign? No. So the result is negative, just like over here. Okay, so let's go back to our original problem, and then I'll give you a couple of practice ones because our time's looking good here. Original, back to the top. Uh-oh, spoiler alert. Don't look at that. Don't look there. Let me highlight the fact that I do not want you to look at that. Okay. Don't look there. So, negative x equals 6. Divide both sides by the coefficient. Because this is multiplying, you may not realize that. Divide by -1. And let's see what the visual result is. Here we have a positive and a negative. We divide both sides by -1, which turns us into, oh wait, I had that all backwards. We had a negative and a positive, and now we have a positive and a negative. Do you realize? Here I just saw something. So divide both sides by the coefficient just like we've always done. In this case, it's a -1 is the coefficient. So we just divide by -1. I'm curious, hey, what's 2 divided by -1? -2, right? Opposite signs, negative answer. Here's another question for you. What is 2 times -1? It's the same thing, right? I wonder if that means if I had the original equation and just multiplied everything, just because I don't like that negative sign, multiply everything by -1, wouldn't that give me the same result? Distributive property, same sign, positive x, and then distribute, which just changes the sign here. Oh, look at that. So the trick here is if you have a problem like we started with, it does not matter if you divide or multiply, which makes it a tricky thing to teach because there's no absolute answer. I can't say you must multiply or you must divide. Both sides. If you do that, the visual result is the signs of everything on both sides will change. And you could do this in any situation. Perfectly legal. You will not get arrested. And now I'm making all those annoying sounds because this video is over. And instead of being a no-cap video, which it was for a while, that's not annoying, is it? There we go. And we used a highlighting pen. Very nice. Thanks for watching. Have a great day. using these crazy math tricks. Goodbye.